Everyone, thank you so much for coming to this session. I hope you're all doing well this afternoon. I'm really excited to share about this project, but first I will introduce myself and tell you a little bit about how I got involved into this research. So my name is Ivy Petzinger. I am a chemical engineer and researcher. I studied chemical engineering at Case Western Reserve University as an undergraduate student from 2014 to 2018. And then after graduating, I served in the Peace Corps as a volunteer in Tanzania, which is a country in East Africa, just below Kenya. And in Tanzania, I taught math and science to high school students, which I absolutely loved. I loved my job, my students, the teachers I taught with, the village that I lived in. I loved everything about it. So I was very sad when I got evacuated due to COVID. Peace Corps evacuated all volunteers just with the uncertainty of everything going on. And so upon returning home, I was pretty excited to hear about this project as it aligned very well with my background, my interests. And so with that, I will delve into what this project is all about. So the research project that I am presenting on today is a collaboration between Case's Chemical Engineering Department and STEM high schools in Ethiopia. And Ethiopia is a country also in East Africa, just above Kenya, so not too far from where I lived the past 2 years and was teaching high school. And the goal of this project is to take natural resources that are found in nature and to turn them into higher value products that we use in our everyday lives. So really quickly, I just want to check in. Is everyone hearing me? Is everything going okay? Because I don't see anyone, so I just want to make sure everyone's on board. We can hear you. Okay, good. Good news. All right, so goal of this project is taking these natural resources, raw materials in nature, and turning them into products that we use every day. So to dig a little deeper into that, nature, if we go out into nature, it provides us with what we need to survive. So for example, there are fruits and vegetables that we can go out and gather, that we can grow, and that provides us with the nutrients that we need. There are animals such as donkeys, which can carry goods for us. There are trees where we can get wood to build homes. There are rivers and bodies of water where we can go and clean ourselves and wash ourselves. And we can communicate by talking to the people around us. But we can improve the quality of our life if we go beyond what we just naturally find out in nature. So for example, automobiles and airplanes can carry goods a lot faster and further than a donkey can. We can construct large and strong buildings, bridges from concrete and steel, as opposed to just wood from trees. We can become more clean and stay healthier if we use soap and shampoo and toothpaste. We can communicate with each other better if we create paper and print things in newspapers and in books than if we just talk to the people around us. So as engineers, it is our job to figure out how to make these higher value products, starting with the raw materials and the things that we find outside in nature. So we'll use scientific principles and transform starting materials that we find in nature into the products that we want to improve the quality of our lives. And yeah, so in this project, that is what we do. We are creating useful products that we use every day, specifically in the labs and in this research that we're doing so far. We create oil for cooking, soap for cleaning, diesel to fuel our cars and other vehicles, and paper for reading and writing. And we do all of this starting with plants, specifically the seeds and stalks of plants. So plants have many different parts. There's seeds, flowers, leaves, stalks, and each of the different parts have specialized functions, and each of the different parts are made of different types of molecules. So the seeds of plants, actually, they have energy in them, which allow, their function is that, the function of the energy stored in seeds is to allow the seedling to grow before it has leaves to generate energy on its own from sunlight. And so the energy in seeds is stored in oil molecules that are held in tiny sacs within the cells. And so we can use something called an oil press, which we create and use in these labs, which will allow us to create a high pressure and allows us to separate the oil from these tiny sacs in the seeds from the solid and the rest of the material in the seed. So then we can use that oil either for cooking as cooking oil, or we can use that oil to make more products. And we use the oil that we get from these seeds as starting products for other reactions to make soap and biodiesel. And then a different part of the plant, the stalks, are made up of different molecules. And the cells that make up the stalk of a plant are very strong and stiff in order to support the plants and hold them upright. So for this reason, the cells in the stalk have thick cell walls made up mostly of rigid and strong molecules called cellulose. So in the lab, we can separate these strong fiber molecules, and we use something called vacuum filtration. And so we separate these cellulose strong fiber molecules, and then we lay them flat and distribute them, which we can then let dry, and that creates paper. So that's like an overview of the goal of these labs and this project that we're working on. And I have some videos of some of the labs, starting from the materials we find, or the raw materials we find out in nature, and creating the products. So I will start with showing you all a short video of creating oil from seeds that we use an oil press. And so I will share my screen. If I can get some confirmation if this works, that would be great. So here, share screen. Share. And can everyone see the YouTube video now? Can anyone confirm that that is what is showing? See, don't see any answers yet. Okay, I will start this video and we will see. Hopefully it will work. Yes, you see it. Okay, awesome.
Started on the experiment. It is time to get started on the experiment. Be sure to have properly assembled the oil press by following the instructions in the oil press setup section of the workbook or video. We need to start by getting our seeds ready. We will be using sunflower seeds in this video, but other seeds and nuts will work as well. The first step is to get the mass of the seeds. Place the empty container on the scale and record the weight of the container. Now fill the beaker with about 200 milliliters of seeds and record the mass. Reset the scale. Weigh and record the mass of the empty oil collection jar and the empty 500 milliliter beaker that will be collecting the dry cake before beginning our pressing. Place the jar under the feed hopper to collect oil and the 500 milliliter beaker under the expeller to collect dry cake. It is optional to use the alcohol lamp for 5 to 10 minutes to heat the press before starting the pressing. To begin the pressing, first we add seeds to the feed hopper so that it is mostly full. Make sure not to knock over the hopper or the seeds will go everywhere. Then place your hands over the expeller exit so that no material can come out. Slowly begin turning the handle. Make sure the seeds fall from the feed hopper into the shaft. The pressure on your hand from the exiting material will increase, but keep your hand in place. When the pressure is so high that you cannot keep the material from coming out, remove your hand. Continue turning the handle. Dry cake will begin to exit the expeller. There may be some oil present near the expeller exit at first. Oil will not immediately drip into the collection jar. After some time, oil eventually drips into the collection jar. Continue turning the handle until all seeds in the hopper are expelled. Rock the handle back and forth several times. A lot of oil will come out at this time. Then refill the hopper with more seeds and continue turning the handle. Do this until all of the seeds have been pressed. Make sure to keep turning the handle in both directions until no more oil is dripping into the collection jar. When you finish, weigh and record the mass of the oil collection jar. Also, weigh and record the mass of the beaker with dry cake. Now we will observe the oil. Look closely and note the color and that there are small solid particles dispersed in the oil. To get clean oil, these particles should be removed. Let the jar sit overnight and the solid particles will settle to the bottom of the jar. Now that the particles have settled to the bottom, we will use a pump to transfer the clean oil to another container. First, connect two barb connectors to the tubing on the pump. Using these barb connectors, connect one piece of tubing to the inlet port of the pump and another piece of tubing to the outlet port of the pump. Plug the pump into a power outlet. Weigh and record the mass of a clean beaker into which we will transfer the clean oil. Place the open end of the outlet tube into the collection beaker. Position the open end of the inlet tube into the clean oil at the top of the jar and hold it so that it remains in the clean oil and does not touch the solid particles at the bottom of the jar. Turn on the pump to transfer the clean oil to the beaker. Be careful to keep the inlet tube positioned so that only clean oil is transferred and no solid particles from the bottom. Stop the pump before the end of the clean oil is reached. It is important that no particles be transferred with the clean oil. It is okay if some of the oil is left behind and not transferred. Weigh and record the mass of the beaker with the clean oil. Also, weigh and record the mass of the oil collection jar with the remaining dirty oil. Now it is time to calculate your results.
Okay, am I back? Did everybody enjoy that video? Okay, cool. I did not know that they can see this. Okay, awesome. So if anyone has any questions, please feel free to put it in the chat. But basically that video was very detailed because that is also being sent to everyone that will be using this workbook and this lab kit. So it has details. But the overall idea is that we use this oil press. We load the sunflower seeds or other types of seeds or nuts into the feed hopper on top. And then we create a high pressure by cranking the press. And that separates the oil from the solid and the rest of the seed. So the final product was the oil. And then we use that oil as a starting material in other labs in this project, such as the soap making and the biodiesel making, which I do have some videos of the Biodiesel Lab, for example. And if you are interested, I can show you that. But also I want to open this up. I want to make this session as interactive as you would like. So if there's any other questions, if you guys want to share or chat, please feel free. Like I said, I can allow you to talk or you can put it in the chat box. So please tell me what you guys would like. Would you like to see another video on making biodiesel? Any questions about this project? See, allow, I'm not sure. How can learners of my school get involved in this lab? That's a good question. My supervisor, Professor Daniel Lax, was not able to join the call today, but I can give you my email. You can definitely reach out and we can discuss potentially getting involved because we'd love to get involved with more schools and students. We've been doing some trials with some students in schools here nearby in Cleveland, and we're collaborating with STEM high schools in Ethiopia as well as some graduate students, chemical engineers in Ethiopia. So if you are interested, I will put my email in the chat box and feel free to reach out and we'll be in touch. Let's see what else. I see one, can you share how you decided on going to school for engineering, which I can definitely do. Maybe I'll end with that so I can keep the focus on this project. And then at the end, if anyone is interested in that, you can stick around and I'll answer that. It would be great to watch another video. Okay, I can definitely show the video of the biodiesel. And are the seeds and nuts used local? So yes, we did use local nuts here from Cleveland, but we also have counterparts in Ethiopia working on this, and they used local seeds and nuts from their area as well. And it's been very beneficial to be very communicative and collaborative with them because we have learned what works best there. We've learned about the economics there and what is cheapest, what's most readily available, so what can work best for them as well. And for example, too, another thing I was talking about is making paper. And we actually, locally, we use celery as like the stalks of the plant, but they have something called false banana in Ethiopia that's very readily available. And so that is what they use, but they got very similar results and it worked as well.
Okay.
Yes, water is a liquid. Yes. Okay, so let's see. I had a question from David. Is there a way other than the pump to maximize the oil you are able to get to the clean used cup filter? Okay, so David, yes, there are other ways that, okay, so we used the pump to get the oil out from the top because there was in the beaker, there was oil on the top and solid on the bottom. Now you can just pour the oil out from the top and stop before you get to the bottom. But a pump is actually a better way to do it because, for example, if we were to make these on a big scale, not just small beakers, but a big scale with big containers, for example, in a factory or something, we couldn't pour a big heavy container. But if we use a pump, that we can use no matter how big the container is. So that's why we chose to use a pump in this experiment. If there aren't any more questions right now, I know someone said they would like to see another video, so I can show the video of us using the oil that we made in the last video to make something else called biodiesel. And biodiesel can be used in cars, trucks, or other vehicles to be able to fuel the vehicle to move. So I have some videos of that and I can share that. Okay, does that sound good? So here is another video. The beginning is just some preparation, the very details of how to do the lab. But I'll start with when we add the oil that we made in the last lab to the other starting materials, and we'll shake the jar, which will make biodiesel.
You can use other vegetable oil. Also, you can use the oil you pressed from seeds in Chapter 2, or you can use oil that was purchased from a shop. Be sure to measure and record the mass of the oil. Now we will slowly pour the oil into the jar with the methanol and place the lid on when finished. Notice if the oil and methanol mix or remain separate. Record your observations. Notice two separate phases, the oil on the bottom and the methanol lye solution on top. Now we will shake the jar vigorously for 5 minutes. Start a timer. Shake the jar vigorously for 5 minutes. If you get tired, you can use your other arm to keep shaking vigorously. You can also take turns shaking with other classmates or students. After 5 minutes, we set the jar down and then observe how the contents have changed inside the jar due to the shaking. Notice there is only one phase now and no separation like before. Now let the jar and its contents sit undisturbed for about 15 minutes. After about 15 minutes, the biodiesel and glycerol products should begin to separate, with the biodiesel floating on top of the glycerol. Examine the jar carefully to look for this separation. You may need to hold the jar at an angle and look closely to see the separation. We need to be gentle when holding the jar so we do not reverse the settling. Now let the jar sit overnight to allow the biodiesel and glycerol to fully separate. The lye catalyst and unreacted methanol will be dissolved in the glycerol.
So that's the first video, day 1 of biodiesel. But where we ended in the jar, there's both biodiesel and some other materials. So after one more day, you let it sit overnight and they separate. And then we use a pump again to get the biodiesel off the top. And then we can use the separated biodiesel as fuel in a car. And we can actually put that in a lamp and burn it to show the fuel properties. So here I'll show you guys that. So here, now that we had the biodiesel made, so earlier in this video, we used a pump again to separate. So you can see at the beginning, we have two layers on top and bottom. There's the biodiesel on the top and the other materials on the bottom. So we don't want those other materials. We only want the biodiesel. So we use a pump, again, like we did in the first video, to separate. We have tubes, and we use this pump to separate the material from the top from the material from the bottom. So it pumps the material on top through this tubing into this empty beaker over here. And we will end up with only biodiesel in the beaker. And we leave the other material in the jar. And then we can pour this biodiesel into a lamp and burn it. So you'll see here.
And zero the scale. Pour the biodiesel into the graduated cylinder and record the mass and volume of the biodiesel. Pour the biodiesel you made into a lamp. Do not fill the lamp more than halfway. Fully wet the wick with the biodiesel. Thread the wick through the hole in the lamp's cap so that about 1 centimeter of the wick is above the cap. Place the cap in its position on the lamp with the bottom part of the wick immersed in the biodiesel. In a well-ventilated space or in a fume hood, light the wick. Observe how the lamp burns, including the height of the flame and the duration that the lamp burns. Compare the operation of the lamp with a lamp that burns vegetable oil.
All right, so that's another lab. That's the Biodiesel Lab. And in that lab, we made fuel for cars and automobiles. Was that cool? Did everyone like that? In both stages, are the leftover materials usable? That's a great question. And sometimes the leftover material can be used. And if it's possible that it can be used, that's a great thing to do because then you won't waste anything. So actually, that's a good point. And I do see we are over time. So I know we probably have to finish here soon. But in answering this question really quickly, I will say, so for example, when we make paper, we can use something. Well, we used celery here in the United States, but like I said, we're working with schools in Ethiopia, and they have sugar cane over there, and sugar cane can be used. It also has this, those strong, rigid molecules that we need to make paper. And it's actually really good because the sugar cane is used to get sugar, but then the materials that we need, the strong cellulose fibers, those are not used to get sugar. So that's actually just waste material that would be thrown away, but we can use that waste material, and instead of throwing it away, we can use those stalks and we can use that to make paper. So that's a really, really great question. And if it's possible to use something instead of throwing it away, that's wonderful and helps financially as well. It helps save money and makes starting materials very cheap or free. But we also have a lab where we can make paper from old paper. So if there's paper that you use for homework and you don't need it anymore and you would throw it away or recycle it, you can actually use that paper and tear it up and put it in the lab, and you can use it to make new paper. So that's another example of recycling and using materials that could be waste, but putting them to good use to make new product. So Dave asked me, can you share how you decided on going to school for engineering? So for me, I knew from my studies, from my school and middle school, elementary school, and high school, I really liked math and I really liked science. And so I had heard about engineering and I looked into it and I was interested. I didn't know what I wanted to do yet, but I knew that engineering uses a lot of math and science. I knew that I loved math and science. And once I learned a little bit more about engineering and what engineers do and how much they use math and science, that's really what led me into engineering, because I figured if math and science is something I'm good at, I'm strong, and I love, and engineering sounded really interesting and cool of how to use math and science and really apply it to everyday life to solve problems, I thought that sounded pretty cool. And then I started tutoring and engineering. All right, well, thank you all for coming. I hope you all have a great day. Bye.